Solve the systems of equations below using the method of your choice. Check your solution if possible. So I can use anything. So what's efficient? What's an effective, efficient way to solve these? So in the first case, I'm looking at this and hey, the first equation gives me a very nice substitution for y. So I'm going to replace y in the second equation with this value 7 minus 2x. So let's rewrite the second equation. It is 2x and then plus y, but playing the part of y will be 7 minus 2x. And then that should equal the number 10. So if you look here, I did throw the parentheses here because I just want to illustrate the fact that, yeah, there is a positive 1 factor that I could push through to both of these, right? I really adding the whole thing, but it doesn't change anything if it's a positive 1 sitting outside of there. So this is really just 2x plus a 7 and then minus 2x. And we notice that these are opposites of each other. When I combine 2x and negative 2x, I get 7. 7 equals 10. I know that these are parallel lines. So there's no solution here. In fact, if I was to rewrite this second equation, right, in y equals form, this would be y equals negative 2x and then plus 10. So this one you can see has got it's got a slope of negative 2. This one has a slope of negative 2. The first one has a y-intercept of 7. This one has a y-intercept of 10. So they're clearly parallel lines. There's no solution there. So that's done for A. Now let's move on to B. B, I'm pulled to substitution again because this is a very nice substitution for x. So I'm going to replace x in the second equation with 3y minus 1. So I've got 4 times x. Playing the part of x is 3y minus 1. So you can see I'm just rewriting the second equation, right? So I've got 4 times x. That's what I've written. And then minus 2y, and that equals 16. So that's the second equation perfectly. Playing the part of x is 3y minus 1. So let's go ahead and push through this factor of 4 to each of these terms. When I do that, I get 12y minus 4, and then minus 2y, and that equals 16. 12y minus 2y is 10y minus 4 equals 16. If I add 4 to both sides, we have that 10y equals 20. And then finally, if I divide both sides by 10, we get that y is the number 2. So y is 2, but we don't know what x is. That's okay. This very first equation gives me a nice way to figure out x. It says that x is simply 3y minus 1. So let's plug in 3 times 2 minus 1. That gives us 6 minus 1. That gives us that x has to be 5. So I think we have our solution. We believe that x is 5 and that y is 2. And if I plug that through into the original equations, 5 and 2, let me check this in us. Let's see, 5 and 2. So this is going to be 3 times 2 minus 1. And is that the same as 5? Yeah, 6 minus 1 is 5. It checks in the first equation. What was the answer again? 5, 2. So let's plug 5, 2. Let me write this down. I'll forget it. 5, 2. So 4 times 5 is 20 minus 2 times 2, which is 4. Yeah, and is that the same as 16? Certainly. 20 minus 4 is 16, so it checks in the second equation as well. So our solution is x is 5 and y is 2.